Our project is the Smart Parking System. The Smart Parking System consists of 4 components: the license plate recognition system, the QR code generator system, the Android application, and the web application. The Firebase Cloud is the storage of the 4 system components. The 4 system components communicate with each other via the Firebase Cloud. The Android application has the following functionalities: sign up, charge account, find the closest park from the current GPS position, log in, log out, view the availability of the parks in the city, view my balance. The QR generator has the following functionality: generate a QR code that has an account details of a client and store it in the Firebase Cloud. The license plate recognition system is the core of our project and has the following functionality: recognize the plate number of a vehicle in Raspberry Pi from an image that is captured via the Raspberry Pi camera, and compute the parking bill cost of the vehicle and store the bill details in the Firebase Cloud. The web application has the following functionality: recognize the plate number of a vehicle from an image that is captured via a mobile camera and view the details of the vehicle's owner. The Smart Parking System storage structure in the Firebase Cloud consists of several nodes. The parking nodes contains the name, the total parking spots, and the GPS coordinates of each parking. The QR code, keys, and payments are used to ensure the system reliability and security. Users and users info are used to store all the users' information. The records are used to store the final bill details. Android application. The user should install the app first and create a personal account in order to utilize the Smart Parking System functionalities. We have already installed the app and we are going to create a new account. In order to create a new account, we have to go to the sign up page, fill the required information, the first name, the last name, the username, the vehicle number, the password, and the phone number.
We can see that the account details are stored in the Firebase cloud.
Is created, the balance will be 0. In order to see the balance, you have to be logged in. In order to log in, we have to enter the required information: the username and the password. Here we can see the username and the balance. The balance is 0. The user can switch between several accounts through the logout functionality. Now we can see that the username and balance are no longer visible.
To charge the user's account in our Android app, a QR code is used and should be bought in advance. This QR code is generated by our agents, which are distributed in different locations. In our smart city, the agent inputs specific information such as username, plate number, and balance to generate the code as a PNG file. A secure key is also added to generate a real QR code and to prevent the generation of a fake one. The generated QR codes are printed on papers and given to users. The users utilize the Android app to scan the QR code and extract its information. The extracted information is sent to be stored in the Firebase cloud. At this step, the balance is charged and the users can utilize the parking service. One of the most important components in our project is the license plate recognition system. This system includes two main blocks: plate localization and digit recognition. Plate localization consists of two parts: region segmentation and plate non-plate classification. The digit recognition includes two parts: digit segmentation, and digit classification. The recognition system is implemented on a low-cost hardware platform, such as Raspberry Pi. The Raspberry Pi is connected to Internet to access the cloud storage platform. This is called Internet of Things. The input of our system is an image, which is captured by a camera. The camera is attached to Raspberry Pi. The captured image is entered to label connected component for segmentation. Then, the segmented regions are passed to Convolutional Neural Network, CNN. The output of CNN is a license plate. The plate is entered to another label connected component for digit segmentation. The segmented digits are passed to CNN for classification with 10 classes. The output of recognition system is the plate number. When the car enters the parking area, the camera attached to a barrier captures an image and sends it to plate number recognition. The system looks for the plate number in the Firebase cloud to check the balance. If the plate number is available and the balance is above the predefined threshold, the user is allowed to enter. The temporary bill of user is created and stored in the Firebase cloud. This bill contains information such as username, plate number, and timestamp. When the vehicle leaves the park, the same procedure is repeated. The image is also captured, and the Raspberry Pi sends the recognized plate number to Firebase cloud. The time between in and out is calculated for this plate number, and the final bill is issued. The user's balance is updated after deducting the parking fee.
The project has a web application that is built by using TensorFlow.js for machine learning in web. The objective of this web application is to take a picture of a license plate by a smartphone. This image is passed to plate recognition system. The system recognizes the plate number which is connected to the database. After that, the details of the car's user, such as personal picture, first name, last name, and telephone number, are displayed on the web page. The manager of the parking area can utilize this application to get information about the car's owner to contact him in emergency situations. For example, parking for a long time. When the user wants to park, our Android app helps him or her to find the closest parking area. The app asks him to open the GPS. The GPS gets the coordinates of current location that is utilized in the Android app and compared to a predefined set of GPS coordinates of available parking areas. The distance between the current coordinates and each one in the set are calculated. The distances are ordered from the shortest to the longest in a list. The number of parking slots in each area is also displayed in the app interface.